Thank you. Yes, my name is Beth Skurrie. I work for DIS, a technology consulting company that is based in Melbourne and Sydney. We like to build products for ourselves and our partners, like the Qantas Travel Companion app, or the NIB Nibby chatbot, or realestate.com.au's VR real estate app. Now, today I'm going to talk to you about how you can deliver customer value faster using contract tests. Before I start, I just want to get a little bit of a feel for who's in the audience today. When it comes to testing, I guess there's two ends on a spectrum of the way you approach it. You might want to have absolute, utter confidence before you deploy, so you test and test everything to the nth degree before you release. Or you might prioritize speed, so your approach might be more along the lines of, let's just stick everything out there as soon as we can, and we'll just rely on the fact that we're moving very fast to recover from any mistakes. Now, obviously, most of us are going to be sitting somewhere in the middle, but just to help me get a gauge of my audience, stick your hand up if your teams would fall more on the confidence side of that spectrum. Yeah, a lot of confidence people. And if you're more on the speed side of that spectrum, stick your hand up. Pretty even split, actually. Okay, so let me start today with a story. Now, it's a story of a made-up company called Soundify. But it's not really a made-up company because it's not really a made-up story. It's a story that we've all lived through. It's a story about solving problems and then discovering new problems. Let's imagine that I've been working at Soundify for a few years, and you're joining my team, so I'm going to give you a bit of a history of the company. Now, Soundify is obviously an audio music streaming company, and we're going to be running a new project to integrate some new sources of audio. Now, there are three teams that are going to be involved in this project. There's the core platform team, which looks after the core platform. It provides the enterprise-wide services and is going to be doing a lot of the grunt work in this project. Now, there's the experience team that looks after the React UI, and there's the API team that looks after the API that sits between these two projects, these two services. Now, we've ended up with this structure after lots of restructures to help us become more agile. Now, when it comes to the working rhythm, different teams in our company used to work with different patterns. The experience teams and the API teams could deliver pretty quickly, and they would iterate quickly and deliver often. But the core platform team proceeded to work as it always had, the old school of software development with a big upfront design, and then a build, and then an integration test phase, and then a release at the end. Now, the problem with this was the API and the UI teams had the ability to release customer value in a fairly consistent manner over time. But whenever we had anything that relied on the core platform, we had to wait until the integration test phase of the core platform before we could find out if what we had built was actually going to work. Now, the predictable outcome of this was that there was always going to be problems at the end of the project. The release graph of the customer value for the core product looked like this. Nothing, 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 everything. From the program perspective, whenever we needed to make changes that involved the core, we had to release the features untested and toggled off. Now, the predictable outcome of this was those integration issues. Now, it would always require rework. We'd have to go back and make changes to code that might have been written weeks or months ago, as everyone tried really hard at the end of the project to make sure all the services lined up to get ready for that final release into production. Things got stressful and timelines got dicey. Pretty much everyone was unhappy with the situation. Our customers were leaving us for competitors who could deliver cool new features more quickly. Our business owner was unhappy because we were losing customers. The delivery manager was stressed about the risk and the amount of rework and the wasted time. And the teams hated the context switching and the rework and the delivery stress. It was clear that something had to change, and that bottleneck was the core platform. So we did the obvious thing, obvious but not necessarily easy. We talked the core platform into changing their working pattern so that they would also release in 2 weekly iterations along with the rest of us. Now, change is hard, and the team wasn't really keen on this. But on the upside, we started to see a customer value graph that looked like this. We get small batches of customer value out more consistently over the project. The smaller feedback cycles also meant we were able to respond more quickly to changes. Now, the iterating was really helpful because it meant that we could find those integration bugs earlier, and it reduced the risk of the project. However, we'd fix some problems and we'd introduce some new problems. There was now a whole lot of overhead in this release process because the core platform was still released manually. We need more testers to prevent regressions. And we still had a 4-week turnaround on our integration bugs because it would take 1 iteration to find them and then another iteration to fix them. By the next project, the core team had gotten completely sick of doing these day-long manual releases, so they spent some time up front to automate the process. Now we had 3 constantly moving projects, so we introduced a suite of end-to-end tests. Because this is how we do modern software development, right? We automate all the things, we iterate, we test all the things, we automatedly test all the things. And we felt pretty smug as we looked at how far we'd come in the last few years. We'd gone from a small team with a mostly manual process to having multiple teams and automated everything. We're living the dream, right? But it didn't feel as good as we'd expected. Yes, we'd been able to reduce the integration risk on our project, and we had a bug turnaround time that was within a few days, and we were able to deliver bits and pieces of customer value throughout our project. However, we'd solved some problems and introduced some new problems. We had these slow tests. They took multiple hours to test everything that we thought we should. They were really easy to break and very hard to fix because they covered so much code. They scaled really badly because to test variations, you had to go through steps you'd already covered to get to the bit that you actually cared about. The failing tests became the norm, so they got ignored, and they weren't actually giving us very good feedback on our code quality. And all this test maintenance took away time from actually doing the important thing, working on the features. We'd fixed some problems, yes, but we'd introduced some new problems. Instead of that acute pain at the end of the project, we had this constant background pain. And even though we were delivering customer value and all the things we thought we should, we still had this multi-day turnaround on our integration bugs. It felt like the tests were breaking all the time. And the old school developers on the core platform yearned nostalgically for the good old days when they could just sit down and code in peace for weeks without talking to anybody and then get it all working in the end in one pizza and Coke-fueled marathon. They didn't want to appear out of date amongst all these hipster React developers, but secretly they were asking, why are we doing these integration tests? Now, it might seem like a really dumb question, but it's actually a really good question. Why do we do integration tests? What goal are we trying to achieve? Well, we know in any system with more than one moving part, there are going to be integration issues. It's not a matter of if, it's a matter of how many. We want to find those integration issues before we go to production, not after. Now, unfortunately, these end-to-end tests that we'd written weren't really paying us back. They were high cost, but they weren't really helping us find the bugs. And we realized we'd gotten things a little bit out of balance. Now, everyone will have seen the testing pyramid. It expresses the idea that we want a lot of fast, low-cost unit tests, fewer integrated tests where we use real components, and then fewer, again, end-to-end tests that test our entire system. Now, the unit tests are really good because they give us quick feedback, and they tell us exactly where the problem is when they fail. But they don't give us a lot of confidence because their scope is small. The end-to-end tests are really good for giving us confidence, but they give us slow feedback, and when they fail, they don't really tell us exactly where in the process things have gone wrong. Now, in our enthusiasm for testing the world, we had far too many end-to-end tests, and they were testing too much. We really wanted to cut them down to a manageable set of happy paths, but we were afraid that as poorly as they were working, if we cut back on those tests, we would be letting more bugs into production. Now, give me a nod if this is a dilemma you have found yourself in. Yeah, we don't want to have too many tests, but we don't want bugs in production. What if there was another way? What if we could find these integration bugs without having to run these integration tests? Does it sound crazy? Let me walk you through a scenario. Now imagine two integrated components. We're going to call them the consumer and the provider. Now instead of using a real provider, we use a mock provider, and we test that the consumer makes the right calls to the provider and can handle the responses. This is nothing new. Like, we do this all the time, right? But what we're missing from this diagram, as you can see, is the other half. We're missing the tests that show that the provider can accept the calls that the consumer makes and handle actually returns the responses that the provider expects. If we have these two sets of tests, we've achieved test symmetry. We've tested our consumer with a mock, and we have tests that show that our mock behaves the same way as our real provider. Test symmetry solves a lot of problems. It gives us really fast feedback. You don't have to deploy the world to run these tests. You can run them from your local machines or from just a self-contained CI environment. Because you're running these tests in a controlled environment, you can use your normal debugging tools, so they're much easier to fix problems when they happen. You don't have to trawl through hours of Splunk logs. However, we've fixed some problems, and we've introduced some new problems. We now have two different sets of tests in two different code bases maintained by two different teams. And they might start off looking nice and neat like this. But sooner or later, somebody's going to make a change, and pretty soon they're going to look like this. And there won't be anything that fails to let us know about the mismatch in expectations. As every developer knows, this is the problem with mocks. What we're missing here is a way to keep these two sets of tests in sync with each other. We're missing the contract. Let's go through that testing diagram again, but this time we'll make an important change. All right, we test that. The consumer makes the right calls to the provider and can handle the responses it expects back. But then we record that request and the expected response to a file. This is the contract file. Then we take that file over to the provider, and we replay the request, and we look at the response that comes back and make sure that it matches the expected response. This is called verifying the contract. And we've just achieved the benefits of integration tests with the speed and ease of unit tests. Contracts help us solve the problem of test symmetry. And instead of introducing a whole heap of new problems, we actually get some really good benefits. This fast feedback that I mentioned means that our integration bug turnaround time has gone down from months or weeks to minutes. If you're on the provider side, you'll know before you commit whether or not your code is going to work with all the consumers. So you're reducing the number of bugs that even get committed into the code base. contracts allow you to make changes quickly. Because each pair of services has its own contract, you can identify which services are affected when you need to make a change. Contracts allow you to deploy independently. Once both sides of the contract are passing, you can feel free to deploy either side without having to pre-test groups of applications in a big batch and then deploy them all together. Big integration test suites create a bottleneck, but contract tests allow each service to move at its own pace. Now, one of the best side effects of using this pattern is that you're actually going to end up with better designed APIs. Now, the process that I've just described to you before is called consumer-driven contracts. Traditional API design went something like this. I have a database, and I'm just going to get the data out of my database into an HTTP response in the simplest way possible. Ruby on Rails, I'm looking at you here. Then we make sure that the consumer makes the right calls to the provider. Consumer-driven contracts turns that process around. We start by asking, as a consumer, how do I want to use this data? What format makes sense for me? And then we make sure that the provider can actually meet those expectations. This means we end up with an API design that is built for real-world situations. It's TDD for services. Now, I've told you a bit about what contracts can do for you. Let me tell you a bit about what they don't do. Now, when people start using contracts, especially on the consumer side, they have this tendency to try and use the contracts to make sure that the provider is implemented correctly. The provider is doing the right thing when I make this request. But that's not the job of contract tests. That job belongs to the functional tests in the provider's own code base. What the contract tests are about are making sure that the consumer and the provider have a shared and correct understanding of the messages that are going to flow between the two of them. Similarly, contract tests are not load tests or performance tests. Now, it takes two to tango when you're doing contract tests. It requires one party to write a contract and another party to verify the contract. So they're not the best use case for public APIs. And when I mean public, I mean lots of consumers and you don't know who's consuming them. It's just out there for anybody to use. Good luck writing a contract for someone like GitHub and saying, hey, GitHub, please verify my contract. It's not going to happen. Imagine if you are GitHub and trying to maintain a contract with hundreds of thousands of users. That's not going to happen either. That's where the traditional versioning approaches are more useful. Consumer-driven contracts have this sweet spot for internal APIs where the consumer and the provider teams are few enough that they can actually maintain some level of personal relationship between them. And they're not going to make every integration testing problem you have magically disappear. If you do contract tests, you do actually have to be a bit smarter about the way you test. Integration tests might be a pain in the bottom, but they are conceptually quite easy to understand. It's like trying to prove the strength of a chain by using the entire length to lift a heavy object. Contract tests give you a lot of advantages, but you have to think carefully about the way you're using them. It's like trying to test the strength of a chain by checking the strength of each link individually. Now, if you miss one of those links, you can make no assertions about the strength of the chain. Now, talking of integration tests, you might be wondering, if we have contract tests, do we still need integration tests? Now, the answer, like most things in life, is it depends. I had a bit of a go at trying to express what sort of integration test coverage you might want in your project, and it's come up to be a formula that looks a bit like this. The amount of integration test coverage that you want is proportional to the consequences of a bug making it into production times the time to find that bug times the time to fix that bug. Now, here's an example. Imagine you have some medical software for some medical hardware that can only be released by a technician physically visiting a site. You have some pretty serious consequences if there's a bug. There's a long time to find the bug, and there's a long time to fix that bug. So you're probably going to want a pretty comprehensive integration test suite. However, you're still going to get massive benefits from your contracts because they will have flushed out all those low-level issues before you even get to that integration testing stage. Your integration tests can just focus on the customer value, making sure the features are working at a high level, not that you're making the right HTTP calls. An interesting thing to note about this formula is that it actually describes a feedback loop. The faster you can find your bugs, the faster you can fix your bugs, the less integration test coverage you need, which means your tests are going to run faster, which means you need less integration test coverage, which means your tests are going to run faster. You see where I'm going here? By way of contrast to that medical software example, one of the projects that I worked on personally used contracts. And instead of spending that time on maintaining an integration test suite, we spent time on things that would help us find and fix those bugs quicker. So we implemented really good aggregated logging, alerts, monitoring, and we implemented semantic monitoring in production. One of the techniques we used was synthetic transactions. An example would be placing an order with a known customer ID and making sure that the order data ended up in all the right systems within the right amount of time. Now, because we're using all these techniques and because the consequences of a bug getting into production weren't that severe because there was a manual workaround process, we just skipped the integration testing phase completely. Now, I'd like to tell you a bit more about that project because it started my own journey in this contract testing world. Now, once upon a time, in a place called realestate.com.au, otherwise known as REA, back in 2013, there was a group of developers that were facing that same long list of problems with their integration test that our made-up company was. Now, they recently heard about this consumer-driven contracts concept, so they decided to give it a go on their own project. And that is how the contract testing library called Pact was born. If you were at YOW in 2014, you might have seen the talk that I did with Evan Botcher and John Eves on realestate.com.au's microservices journey and the role that Pact played in that. Now, Pact was first written at REA, but has since become an open source project with implementations in many languages. Now, I've been involved since the early days, since I came across Pact while I was consulting at REA, pretty soon after the first draft was written. And if you saw Katrina Owen's talk before on the bait and switch of open source software, you'll understand what I mean when I say it became an irresistible problem to me. Something quite mathematically satisfying about breaking this equation down and proving that it works on both sides. Also, I hated integration tests, so I had some personal investment in this. So Pact uses this same consumer-driven contracts pattern that I was describing earlier. It has an HTTP mock, it serializes the interactions to a contract, and that contract is called a Pact. And then it verifies the contract on the other side. I'm going to tell you a bit more about that Pact story now, but I'm also going to tell you a bit of a story of something that has not necessarily yet happened. It's a story of what you will encounter as you start on a contract testing journey. I'll talk you through the problems that you will encounter and the way that we fix them in the Pact framework. Because I might have told you a little white lie earlier. Contract testing does actually have a few new problems when you start to use it, but they're more interesting problems than solving flaky tests, so work with me here. Now remember I told you that contract testing has two parts. We have the consumer being tested with a mock, and we have the tests that show that our mock behaves the same way as our provider, and we have the contract that keeps the two of these sets of tests together. Now, the first obvious problem is we've got a contract, the consumer has generated it, how do we get it to the provider? Now, we tried a few approaches to that while I was consulting at REA. We tried just copy-paste, and we tried committing directly into the provider's repo. We tried using build artifacts, but all of these solutions had varying problems. So in the end, given this is the age of microservices, during one of the DS Hack days, we wrote a microservice with a specific purpose of exchanging contracts. It was called the Pact broker. Now, each consumer CI build would publish a Pact to the broker, and each provider build would retrieve the latest version of the Pact from the broker. So whether you use a Pact broker, which is also now an open source project, or whether you use something like S3 buckets, you're going to want a way to automate your contract exchange. Now, contracts tests generally follow a pattern that looks like this. When the provider receives some request, then it will return some response. Here's an example. When the provider receives a GET request for alligator/Mary, it will respond with a 200 JSON representation of our alligator Mary. Now, something we realized as time went on was that we wanted to be able to test the same request under different scenarios. For example, we might want to test how both our consumer and provider behave when there is no alligator named Mary and we get a 404 response back. Now, this is how the concept of provider states was created for Pact. They describe the state that you want your provider to be in when you replay the request so that you get the response back that you expect. They allow you to test the same request under different scenarios so that you can make sure all your code paths are tested. This leads me to something else you will need to face when you start your contract testing journey. You're still going to need to think about your test data because the behavior of your services is driven by the data that they have. Now, when Pact was first written, it was written in Ruby for Ruby microservices, and some of those Ruby-isms ended up leaking into the contract. This was fine until Pact started to grow in popularity at REA, and then it hit its first Scala microservice. Now, at this point, we realized that contracts should be as technology agnostic as possible. They should focus on the messages and not the technology, not the implementation. Now, as a result of this revelation, we pulled the Rubyisms out of Pact and came up with a language-independent method of serialization. But this concept of focusing on the messages also helped us implement Pact for message queues. Now, there are so many different message queues that trying to write a mock for each of them would be an impractical amount of work. But we realized that the implementation details of how the message gets exchanged over the queue could actually be tested elsewhere, leaving the contracts to deal with the contents of the messages themselves. So when you implement your contract tests, consider carefully the level at which you define the contract and see if you can separate the message writing and handling code from the message transmission code. Now, as time went on and the services in our within our projects progressed, the contracts changed. We'd add new fields, and some of the contracts became quite big. And the bigger they became, the more brittle they became. And things would be failing because some capitalization was different or an ID was 1 instead of 2. And this was really, really irritating for a while, until we realized that we actually didn't care about the capitalization of a name, and we didn't care whether an ID was 1 or 2. We actually just cared that there was a name field and it was a string, and there was an ID field and it was an integer. most of the time we didn't actually care about the exact values. When you do contract testing, your contract should be as flexible as possible, but no more. You need them to be tight enough to give you confidence, but loose enough that they don't break with inconsequential changes in the actual data. Now, if you do enough of this contract testing thing, you might want to actually start to create a logic around that and actually serialize that matching logic into the contract itself. Now, because all the code base is being worked in parallel, the builds are running all the time. So pretty much every time a contract changed, the provider build would pick it up. But the time came when this rate of change slowed, and a contract got pushed to the broker, but the provider build didn't run for a few days. And then when the provider build did run, it broke, but nothing of significance had actually changed in the provider. Now, this raised a few issues for us, issues that you're going to face too. We realized that the other services need to know when a contract has changed. We realized that you need a way of introducing those changes in a way that just doesn't break everything. And we realized that contracts are not a substitute for good communication between teams. Now, one of the problems with consumer-driven contracts is that the expectations come before the implementation, because it's TDD for services. Now, TDD works fine when you're working within the same code base and you make the test and you make the change and you can commit them together because everything stays green. But when you have the expectations in one code base and the implementation in another, it's really hard to manage that workflow. So to fix these problems, we realized we needed some new features in the broker. Now, to fix that ticking bomb problem of that contract sitting there without the provider build knowing about it, we implemented webhooks in the provider so that when a contract was changed, we could kick off a new version, a new build of the provider. To enable changes to be made to the contract without breaking everything, we implemented tags, the concept of tags in the Pact broker. Now, tags are like Git branches or SVN branches. And they allow you to keep your non-breaking main line of development while adding new features on the side. Now, this lets your provider work towards implementing the new contract while keeping the main contract green. And then when they're both green, you switch out the new contract over the old contract. I explained that very poorly. Trust me, it works. Once both those contracts are green, the new one can replace the old one. And you've kept all the builds green the whole way while introducing potentially breaking changes. Now, this requires communication between the teams. So to fix the problem of the communication between the teams, in the broker, we did nothing. It turns out that contracts are not a good substitute for good communication between teams. But integration tests never were either. Yes, consumer-driven contract workflow does mean that the consumer team is writing the expectations into a contract file, but that's not to say that the expectations are always right. It's not to say that the consumer team gets to dictate everything to the provider team. It's not dictator-driven contracts. The changes in a contract file are a starting place for a discussion about your API design. They're not a club to beat each other over the head with. Now, finished rant. Let's see where we are in our respective contract testing journeys. We've got flexible contracts. We've got an automated way of exchanging those contracts. We've got a way to bring those changes without breaking everything. It must be time for a new problem. Our new problem is this. The provider knows if the contract has passed because it's running as part of their build. The verification, that is. The provider knows if the verification of the contract has passed. The consumer team is back in consumer team land waiting for the call from the provider to say, yes, your contract has passed, you can deploy. But what if the provider team is busy or they're on the other side of the world, so they're asleep? Turns out that sharing the contracts is only half the story. You need to share the verification results as well. Now, this is a problem that we can fix with technology. We added some logic to the broker and to the Pact libraries to allow the verification results to be published back to the broker and built a CLI for the consumer to be able to retrieve those results. Now we have this full circle of communication. The consumer CI is responsible for writing and publishing the contract. The provider CI is responsible for verifying the contract and publishing the results. The consumer CI then gets those results and deploys, or not. Now, this workflow can actually be short-circuited because most of the time, the contract hasn't changed since the last time you published it. So if the contract hasn't changed, we added some logic into the broker so that the contract is pre-verified. This means that most of the time, your consumer can go straight from generating the contract, publishing the contract, straight into deploying. We don't need to wait on the provider build. Now, you might think this looks more complicated than the traditional integration test suite, and you might be right. But really, it's just surfacing the underlying reality of your distributed environment. When you spread your logic across different code bases, you are creating dependencies between them. Now, you've probably heard the newly invented saying, if you can't deploy your services independently, you don't have microservices, you have a distributed monolith. Now, big integration test suites put this big single gate across all your code bases, coupling their deployments together, which undoes all that good work that you've done in decoupling their code bases. Now, something interesting happens when you publish a contract with every build, every consumer build, and verify a contract with every provider build. You build up this matrix of which versions of your application are compatible with each other. And this becomes really useful, especially in an environment like a mobile application where you're supporting multiple versions of your client. And it's one of the features of the Pact broker that allows you to deploy independently, because you can look at this graph and say, well, I've got an existing environment that I want to deploy a single service into. Which version of my service is actually compatible with all the other versions that are already in there? This means you can start to deploy things one at a time. You don't need to do everything in batches. And all this contract data gives you an emergent living architecture. You can get network diagrams to tell you what services talk to what other services. And the contracts themselves can be turned into human-readable documents that allow people within your organization to find and understand and reuse the services in a really helpful way. Now, I've walked you through a consumer-driven contracts journey using Pact as the example, but there are some other tools that play in this space. Spring Cloud Contracts is a CDC library that actually also supports Pacts. It provides a groovy contract creation DSL, which generates both the stubs and the contract verification tests. The contracts and stubs are shared via the standard Java package management tools like Maven, sorry. Now, one of the most common questions I get when talking about contracts is, but what about Swagger, or Open API as it's now called? Now, technically, Swagger is a documentation tool, not a contract testing tool. However, it can be extended to create a stub on the consumer side and to do verifications on the provider side in a really similar way to contract testing. What you're missing, however, is that ability to run the same request under multiple different scenarios to make sure your code paths are all covered. And you don't have that flexible logic that stops your tests becoming brittle. If you're using Swagger this way, it's actually a provider-driven contract because we're starting with the functionality that a provider can do for everybody rather than documenting the single relationship between a specific consumer and provider. Now, for internal APIs, this has some downsides because it doesn't tell you which inputs and fields each consumer is using. So it's harder to tell what the impact of any change will be. This is why we often, for public APIs, end up creating a new version in parallel, which means we end up having to run multiple versions of our code. For internal APIs, consumer-driven contracts will really give you an advantage over provider-driven contracts when it comes to making rapid changes. Consumer contracts allow you to see the impact of making a particular change and tells you exactly which consumer is using that particular piece of your API and exactly what fields they're using. So you have this concrete list of who to talk to and what to discuss when you need to make a change. What if we could get the benefits of consumer contracts and provider contracts, though? Now, this is a little bit experimental, but I think it has a lot of potential. Atlassian has written this tool that allows you to verify a contract against a Swagger document instead of against a running service. Now, you lose a little bit of confidence here because we've added an extra layer of indirection into this testing process. However, you do get really, really fast feedback. It means you don't need to wait for the provider build to run to know whether your two services are probably going to work together. You just need to swap a Pact and a Swagger file. Now, we're adding support for this workflow to the Pact broker very soon, and I think it could be a bit of a game changer. Now, I've walked you through a fairly sophisticated example of contracts here. It's got all the bells and whistles, how to integrate it into your CI and CD. But what if you're stuck back in that pre-iteration workflow that Soundify was at the beginning of our talk? Now, I wouldn't want you to go back to work thinking, oh, that's all very well in theory, but we can't do contracts because we're not even doing continuous integration. If you can, test your consumer with a mock, write the requests and responses into a file, replay the requests against the provider, and check the response, you can do contracts. Even if you have to email the file to each other once a week, you are still going to get massive benefits because you will have flashed out all those integration problems before you get to the integration testing phase. It's almost more of a benefit to use contracts if you're not doing CI and CD because you have a bigger risk to start with. Now, talking of Soundify, let's go back to the story of our made-up company. Now, last time we talked about them, they were in integration test hell. Those horrible, brittle tests that were making their life difficult. Now, they heard of contracts, and they decided to make some significant changes. So what does their world look like now? They have a fast, comprehensive set of contract tests between each of their services. And now, instead of that heavy, slow integration test suite, they have some specially selected smoke tests that just test happy paths and make sure that the really important features of their service are working. Now, they've got a similar set of tests that run in production so they can find out really quickly if there's any bugs that have made it through to production. And because they've improved their alerting and monitoring, they have a really quick turnaround for their bugs. Now, all these things mean that their graph of customer delivery over time is a very satisfying, constant upwards trend. The customers are happy because their product is improving all the time. The business owner is happy because they're keeping the customers and getting new ones. The delivery manager is happy mainly because their business owner is happy. The teams are happy because they get to spend time on features and not on fixing flaky tests. Now, as a developer, it's stories like this that make me interested in working in IT. We solve problems and we discover new problems. It'd be really boring if there were never any new problems to solve. contracts help us solve the problem of delivering customer value faster. So what are the new problems? Come join us and find out. Now, if you are interested in joining us on this contract testing journey, here's some links to get you started. The site has information on contract testing, things like message queues, and some online workshops for how to use Pacts in various different languages. And also an example of how you can implement your own really simple contract tests without any framework at all. Now, the talking part of this talk is over, and I'd be very happy to answer any questions that you might have.